So in this series of videos, we're still going to be using algebra to evaluate limits. We saw when we were doing the examples using limit laws, it's going to be really tedious to kind of break up a limit into a lot of smaller pieces and then kind of go backwards and figure out what the answer should be. But what we saw, and this is going to be the topic of the first video, is that polynomials and rationals are pretty nice in relation to limits. All right, so just in general, even in the kind of throughout the whole year, whether we're talking about limits, our next topic's derivatives, and then integrals, it doesn't matter. Polynomials are always going to be the nicest functions because they're just kind of numbers and powers of x. There's nothing else that's kind of weird going on. So polynomials are always going to be the kind of nicest case scenario. If we have some polynomial, we want to find its limit, all we have to do is plug the number in. Polynomial, nothing bad's going to happen. There's not going to be any asymptotes or jumps or anything. So as long as you just plug in the number, that's what the value is, and that's what it should be in the first case. So any polynomial, just plug in your limit value, and that's what you get. Rationals are made up of polynomials, so the kind of top and bottom go well together. The only thing we have to make sure is that we're not dividing by 0. So basically, if you can plug in the a into your rational, just do that and you're done. If the bottom ends up being 0, that's kind of a whole separate case. But for right now, try to plug in a. If you get some number, then you're done, and that's the answer. Because if you can plug in a value into a rational, again, there's not going to be any jumps or asymptotes at those values. All right, so that's what you want to do. So for this problem, this is actually a problem we did from the last set of videos. We broke it up into a bunch of pieces. But now that we know how polynomials work with limits, we can save ourselves a bunch of steps. Just plug in 3. And we get 14. Which is the same answer, of course, we got as we broke it all down, but it's a lot less writing and a lot less steps. All right, so here's a rational. Again, rationals, there is something we have to be careful with because we got to make sure we don't divide by 0. But generally, what I always start with is trying to plug in the number. If you can plug in the number and it works, then that's going to be the answer. If it doesn't work, that's when you have to start trying to do other stuff. So let's try to plug in -2. -2 squared is +4, -4 over -6. 4 minus 4 is 0. And this is one thing that'll trip some people up. There's a 0 up top, and that's fine. All right, we just cannot divide by 0, but we can have zeros in the numerator of fractions. And 0 divided by any number other than 0 is just 0. All right, so this one does work out. As long as the bottom does not turn into 0, then you can evaluate the limit and just plug in whatever that number is. All right, so this is the case for polynomials and rationals. All right, those are the ones you kind of should be happy to see. Just plug it in, something you've been doing for a long time in your math career. Plug in the number, the answer you get is the limit.